nii, teoreetiliselt nüüd läks uuesti tööle see asi. nii, kas nüüd on, võiks olla parem, aga peaaegu. Ei, okei on vist. Vaadake nüüd seda YouTube'i laivi. Nüüd on vist nagu okei pilt või? Kas see nüüd hääl ka on huvitav või? Pange keerake endale hääl peale. Kui ma räägin, kas sealt tuleb ka mingit häält teile või? Suurepärane, davai. Palun võtke siin see hääl maha, muidu meil tekib kuradi kaja edasi tagasi. Enda hääl on kõige õudsam asi, mida sa saad üldse kuskilt kuulata. Ma ennast salvestuses kuulan, siis mul alati niisugune tunne, et ma enam üldse mitte kunagi ei räägi mitte midagi, et see on täitsa katastroof. Et see on ikka alati nagu kole lugu. Nii, all right, let's start. So everybody loved the homework 2 so much that now we're going to look into it, how to actually implement it. And at least we look how those things should be theoretically implemented. So there are several different ways how to do it. So the first way, not the first, but not in any specific order, but going by the, let's say from the depth of the layers, the first way how to do it is to implement it directly in the database. So if you have the database support for the triggers and stored procedures and stuff like that, which basically all the major SQL servers have, then you can implement the soft delete there, if you want to. Totally possible. Or you can even use the Microsoft SQL temporal tables and stuff like that. Although, if you do this, then theoretically it's okay. Practically, then you have many issues how to use it from your own software. So how to implement or integrate it with the business logic takes some thinking, because some of the magic is happening on the database side. This is kind of out of your controls. So what you do on the business logic side or in the data access layer is the next question. And the problem is that if your database doesn't support it, so if you're using some kind of SQLite or God knows what, then theoretically you don't have support to do stuff on the database side. Then coming on down from the database, you have to write your SQL sentences or your database operations yourself. So now the question is, where do you actually do it? So one way where to do it is if we are speaking about some kind of ORM or the entity framework, is that you will go and modify the entity framework, which is totally doable. So that would be like really, really nice thing to do actually. So you can overload the entity framework implementation, for example, the save changes, and not example, but this is where you should do it. And mock around in the save changes when the database operations are called. For example, when somebody tries to delete something, you will actually intercept the delete call and modify it to not delete, but to do actual soft delete and add additional data into database and etc. etc. Since in the save changes you will get the full data structure, you can actually walk around in your model and discover all those one-to-many, one-to-one connections from the model, and then you can change the things on the fly. That is fairly complicated thing what to do, because basically, but once you do it, it's universal. It works if the data structure stays the same, then the metadata fields stay the same, then it's basically universal solution. You can use it anywhere. So and you don't have to do anything special. You don't need to know what your database actual structure is. You will discover all those one-to-many relations automatically. So you can just basically walk over your graph and see what is tied to what. But it's technically it takes a lot of reflection. So we are digging around in your own code, so to speak, on the fly, and it's not so easy thing to do, at least initially. It takes years and years, not years and years, but typically many years of programming how to actually do reflection decently. So how to modify and how to create the objects on the fly, and if you actually don't have the person or stuff like that. you have some kind of pointer to type of something, and then you try to create everything dynamically. But it's totally doable. So C# supports it, or .NET Framework supports it. So you can basically program yourself in the code. So you can add additional C# sentences and actual methods during the runtime. The next level where to do it is to do it one level higher. So to do it in your own code, not in the entity framework, but to do with your own entity framework normal operations. So you don't do the dbcontext.persons.delete, but you actually do dbcontext.persons.update something, insert, blah, blah, blah. So you go step by step manually in your own entity framework code. This is much simpler because you control the logic yourself. You know there you have your own data structure, you have your persons and contacts and contact types or whatever, your pizzas. So many of you have the, whatever, why is the meal plan popular? What the hell is going on with you people? Like we have like 20 pizzas and like some 15 or 10 meal plans from the C# examination.
Have you seen what is going on in the shops? It's very popular.
Yeah, let's like we are preparing. So
I think the other one should be also toilet paper, tissue.
Yeah.
Like
Toilet paper hoarding.
Like everybody gets their share.
Toilet paper hoarding and meal plans.
And
sharing.
Yeah, and sharing. So coming back from there, that you will do it in your own code, and this is where we are probably going. So we can look a little bit into the entity framework implementation if somebody really wants to do it in the same changes and do it automatically and universally for all the future implementations. Would be really nice, but this is complicated, so we are mainly looking at how to do it in your own code. So to do it in your own code, it's kind of simple. Business logic as usual, delete, update, etc. So do what you need to do. But now you're in the problem that you have to do it everywhere. So in all your controllers, in all your methods, basically if you do the scaffolding, you get the crude methods, create, read, update, delete, index, whatever is there, and then you have to go and manually change all of those methods.
Yeah.
And you have to write a bunch of code everywhere. And it starts to repeat and repeat and repeat. And even if you think about those crude controllers, which we have created so far, doesn't matter is it about the ASP.NET web controllers, your REST controllers are basically the same. Just the output isn't HTML, but just JSON. But basically you're doing the same business logic there. Just the client is not in the HTML, but you write some kind of C# or Android application against it. But the business logic stays the same. So you have a bunch of database operations everywhere. And they will just multiply and multiply and multiply. And you will probably not just have the crude controllers. Crude controllers are actually not useful in any sense. Typically, we just need to delete them when you actually start to do your application. They are there only initially just to test that is everything working. And when you have starting to write actual code and you actually start to implement your application, all your pizza sharing and how to calculate who owns to who, how much money, and who has paid, and etc., 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 then you will discover that you will need to do those same database operations in several places, not just in one crude controller, but all over your business logic. You need to do some kind of database operations, and you have huge amount of data operations all over your code. And now one beautiful day comes your beloved teacher or your boss and says that, hey, now we need to implement soft delete. Or typical, the next option is that now we need to change the database from the SQL Server to the MongoDB, or we need to change the data access over to the REST APIs. So we are going to some kind of service. We are using external service. We are not using our own databases anymore. And now you start to think, what the hell, man? I have written some few million lines of code. My data operations are all over my code base. And now I need to go and update them absolutely everywhere. So I need to go and figure out all my pizzas, dot updates or dot deletes in all of my code, and go and change all those to the soft update. What the hell? This is like a massive effort. So, and as you're decent programmers, you have the mindset that if I'm writing the pizza.delete the second time, is it okay? Because I'm writing the same code again and again and again. So basically, can we collect those things together? And is this thing working? Should be. Ah, focus is in the wrong place. So let's start. How to do it?
Excuse me, did we skip injection?
Switching around. So let's come back here. So let's start here. So for this, how to solve this problem is pattern repositories. So basic idea is exactly this, what I explained now, that your database code is all over your business logic, all over your controllers. And this, in the long run, will be a huge problem. And it's really, really hard to test. If you write your database code directly into your business logic or into your controllers, it's really hard to mock. So it's hard to write unit tests. So you need to do, we need to do something to collect all our database operations, which are basically all the similar things. We need to collect them into the one single or some kind of logical units, which will deal with those database operations. And the pattern, or how it's called, is called repository pattern. So it's called the data repositories. And typically we do those one repository per one database table, or for the one business entity. So you will get something like person repository and pizza repository and whatever you have there. And initially, how it goes, or how it should be, is that your client business logic, whatever is inside your here, doesn't have any ideas what the hell is going on. So we start initially like with this picture. So your business logic is intermingled with your data access logic, exactly what we have in those scaffolded controllers. That in all those create, read, update, delete HTML methods or actions, we have a bunch of database operations also there. So we try to move those out and collect into their own units. So those units are called the repositories, and we try to go into such picture. So our business logic is totally separate, and we're just moving our business entities back and forth. And our repository takes care how the data is actually saved, where it's actually saved, and if you want to change anything, if the nice teacher or the boss comes and says that now we need to do the soft update or change the database over to totally something different, you will work here inside your repository, and nothing will change on your client business logic. So your web application totally stays untouched. You don't have to do anything there. You will just go into your nice dal.app.ef or whatever folder and or project, and only change the stuff there. So this is the main idea, and this also makes this exactly this soft updates and deletes theoretically much simpler to implement. You only have like one specific place where to do it, and it automatically goes all over your code, and you don't have to do anything specific about it. So initially, how this process was thought out, and what's the big idea? It started from here. So this is your kind of classical way how the data access is done. So if you skip or if you don't use the entity framework or any kind of ORM, so if you think back into your HTML course, into your PHP and MySQL, this is exactly what was going on. So you write your direct SQL sentences, you get your data into some kind of array, so you get some kind of result set, and then you start to iterate over this result set. And okay, if you're nice and you're trying to do some kind of object-oriented programming, then you iterate over your result set and copy everything into some kind of class instances to the persons, and you start to add the persons to the list, and then you send them over to some kind of view that, hey, please now do some kind of for each and render out my persons. So your code gets intermingled, and in the PHP sense, did you do, you developers, in the PHP course, did you do templating?
Yeah.
At least something. So you didn't write like HTML and PHP like intermingled into one single, or at least something. So we try to now move to the next level, that in your own code you only have those methods like get customer by ID, and you don't write your own SQL sentences, and we don't write your own entity framework queries. Everything is behind the scenes from the business logic viewpoint. You just go and ask for the method get customer by ID, and it's not our as a business developers, it's not our duty to know or what the hell is going on there. Somebody else is writing that code. So maybe it's some other team member. Typically, you have to write everything yourself. But at least in the bigger companies or in the bigger development teams, there's somebody else here who is writing those repositories. And what it gives you is like you can test those repositories nicely. You can develop them separately. Some nice architect will write all those nice interfaces and specifications what has to be done, and then you can divide the work away. And plus, this will really encapsulate the data access. It's not important where the data is coming from. So you can really easily change around the implementation where the data is stored or queried from. So you can modify those as much as you like. And there are several ways how to approach it. So there is no hard rule. How many repositories do you actually need to write? So the most common is the first one. So you have one repository per one business unit or domain class, the same way as the entity framework is creating those tables. But it doesn't have to be like that. You can do whatever kind of repositories you actually want to. So that's your own decision, what you want to do. So maybe you only just you make two repositories. One is write and one is read, or do everything as a one huge repository. So there's like several different ways how to approach it, and maybe you will do those based on the business logic. So you have like reporting repository and not just persons repository. So there are several ways how to think it. And now for the fun of or the delightment of Pavel, I will draw some pictures of flowers. So ma mõtlen, kus ma nüüd siis teha saan seda. Ma pean jah, sest seda ei näe YouTube'is on ju. Let me think now. Ma võin pärast seda pilti igat moodi siin jagada, aga ma võin ka siia joonistada. iPadis joonistamine seda, et see läheb nagu echosse, aga see ei lähe sellesse streami. Photoshop on kindlasti üks hea vahend, millega mida iganes joonistada. Nii, aga mis see Photoshop nüüd teeb siis, ma saa aru? Ta on siin selle kuradi slaidi algus. Ahah, see on siia läinud mõnega pärast. No. Ma peaks vast korra selleks kinni panema. Noh, nüüd mu arvuti hakkab hängima, no kuulge. Mul on paremat arvutit või?
Vale esitas. Ei tule ka ikka. Tule seda
no tundub, et Photoshopi käivitamine ei olnud hea idee. Ah? Tundub küll jah, et tundub, et video salvestamine ja Photoshop koos ei ole nagu asi, mis nagu õnnelikuks mind teeks. Siis tuleb ikka tahvli peale joonistada.
Maci Painti analoogi ei ole.
Oot, vaatame, paneme seal kinni, enne kui see asi mul siin kõik kokku kukub.
Tahvel ja fotokas.
Ja ei, seda kindlasti. Nii, lähme siis tagasi sinna, kus me olime. Kus me olime üldse? Nii, siin. Okei, siis ma joonistan tahvli peale, teeme pildi ja topime selle kuidagi siia. Keegi teeme pildi, paneme Discordi, saab Discordi ekraani peale panna. Alright, so during this course, I will draw this picture several times. Several. Uncountably many times. So initially, this picture is kind of like simple. And we start, let's say, with something. We have domain, and let's say, so those are our domain objects. So you have your persons and contacts and contact types and pizzas and whatever you have there. So there are several different ways how to look at it. Let's say, let's put the domain in the center. Everything starts from there. This is what you do as a first step. You design your domain. What is your application about? Then around this, you can wrap a thin layer and say that this is our some kind of SQL database. And basically, your SQL database will do the same structure. So your domain objects are mapped one by one to tables. So you can say that those are, let's say, object. Let's say some kind of pizza. And this is a table. Like this. And then we basically try to draw it thinly. We did entity framework around here. And then entity framework repeated the same pattern and did DBZ. Once again, pizza. And then we wrapped it into some kind of web application. And we did that controller. Once again, pizzas. So basically, we have this straight line through all the layers initially. So this is what you as a developer do as the first go. And now when you start to speak with the client actually tells you that no, I don't want to deal with pizzas. I want ordering pages. I want ordering pages, and there are pizzas and components and who is ordering, so everything is mixed together. And in actual real world, you will discover that your kind of, if you draw some kind of UI here, that they have like kind of such look into a thing. So they have something like, let's say, pizza ordering. And so this, what the client speaks and draws to you, has connections to the several different domain objects and the data store at the same time. So you need all the different data accesses in parallel. You need to check the user, you need to check who is ordering, you have the pizzas, the components, the invoice, the drinks, whatever. So you have like many different data sources you need to, tables or domain objects you need to deal with. So basically, now we try to move this data access away from those, because everything is now intermingled into the web controllers. We try to move it away And initially, the easiest step is really this, that we will do basically a thing which is called unit of work. We will speak about it, what it is, and inside the unit of work, it's kind of a copy of entity framework. We will have the same pattern, we will have our repositories. Pizzas, something like that. And then you have your web here. But now when the client starts to speak about pizza ordering and that you need several different data access points, now the question is it enough just to have those like specific repositories? Or do you want to do some kind of like repositories like this, which go over several entities at the same time? And this is totally up to you. So initially it's easy to come with this straight line over all the domain objects, that you start with your pizza domain object, and then you do the pizza table, and then you do the pizza DB set, and then you do the pizza repository and whatever else is there. But when you start to look from this side, from the client side, what he or she wants, then it looks a little bit different. So somewhere here in the middle you have to meet and decide how do you actually implement this, or how many things you actually need. So typically the thought process, or how it's done, is that you start from this side till you arrive here, and then you come up from this side and see how it meets in the middle, and is it enough? Can you actually use all those repositories? Is this enough, or do you need to do some kind of like intermediate thingies? And then later on we add even more layers here in between, and we do lots of stuff in between every layer. What happens with your objects and stuff like that. So that's the like general design idea, how to approach it. Where's my phone? I need to take the picture. ahah, no minu pilt, siis ei ole ka seda tahvlit, on ju? Jah. Ahah, kohe paneme ülesse. Joel oli üleval igatahes. Ma nägin teda. Jah, teoreetiliselt ma saaks panna läppari nagu veebikaamera nagu tahvlit vaatama vahepeal, kui ajan. Teoreetiliselt võimalik isegi. Ma arvan, et ma saan selles salvestusvahendis siin nagu hüpata nende vahel edasi-tagasi. Nii, open original, where are you? Come here. So that was the picture. Now it's on the recording also. So we start once more. We start from the middle with the domain objects. And then from the domain objects, we get the SQL, we get the tables. From those tables, we get the entity framework with those DB sets. And from the DB sets, we kind of move to the unit of work layer, or the data access layer. And this has the, yep. No minna, mul käib YouTube salvestus käib. Aga mis see nüüd, mis see eho salvestus nüüd teeb selle peale? Okei, et eho salvestus käib nagu edasi. Sa tegid ainult sellele inputi poolele. Okay. Just helistad seda kaamera. Jah, nii siit. And from the entity framework, you have the same you move over to the unit of work and repositories. So we pack all our repositories also into something somewhere, not initially. One from the client side, the client doesn't speak about pizzas and that I want to add a new pizza and delete pizza and users and invoices and who owns who and res contra and etc. etc. So somewhere here in the middle, you have to decide: is your single responsibility repositories by the domain object, are those enough, or do you actually need to do some kind of bigger all over the entities repositories? So this is there is no hard rules. This is up to you. This is purely a business decision, or you as a software developer and architect. So you have to decide what is your approach to it, and basically it just takes practice. So let's start to work on it. And as always, everything starts with an interface. So really, in the object-oriented programming world and in the heavier business applications, everything starts with the interfaces. So some nice architect will write you something like this: that hey, please implement this thingy. So this gives you all the crude methods what you as a junior developer have to implement. So I as architect will give you this interface and say, let's get this thing done. Please write me a repository. And as you can see, you have a bunch of methods, kind of get customer by ID kind of methods, basically person. So give me all those nice persons. And basically find person by ID, insert or update, delete, save everything or save the person to the actual data store, list all the persons, query all the persons, so all including, so you have some kind of functions here, how to specify what you want to include. The problem with this kind of interface is this iGuariable. So if you look back into your entity framework code and remember back into your C# course, this iGuariable basically means that your database query is not yet done. So your database query is executed when you actually enumerate the data, when you do the to list or for each or something like that. So if your repository gives out iGuariables, this is really bad actually. Once again, this is not really bad. This is your like architectural decision, but basically this means that your SQL queries will be constructed outside of your repository. So it doesn't actually change a lot. So it's you can overwrite this all get method and do something here inside your get, but it's not so easy to implement what is going on there. So this is kind of the in the sense of repositories pattern, this is kind of anti-pattern. So you're breaking the repository idea that everything should be encapsulated. You're giving out like semi-finished some kind of queries and you're letting outside users modify what is going on. But theoretically doable. And this is how your typical repository implementation will look like. So using this interface, iPerson repository, I have to implement, or you have to implement all those methods. And initially, it seems like really easy thing to do. And initially, it is a really thing to do. So there's basically just a thin wrapper around DBZ methods. So all of those create, update, delete, you just basically call out, for example, delete by the ID, context people find, and context people remove. So basically, it's just a thin wrapper around DBZ methods and DB context methods for the say changes. So kind of obvious and easy thing to do, actually. But now you collect all your operations into one single place. Everything concerning how do you deal with persons in this case, everything is here. And if you want to change anything, if you want to check that, for example, that the first name always has to be capitalized before you insert it into the database, please, somewhere here is the insert or update method. You get the person reference here. You can modify whatever is there and then update the database correctly. Or if you want to do the soft delete, you go here, you take your delete method and overwrite what the hell is going on here, and you replace whatever you need to replace here. So it's nice way how to encapsulate your data. The only thing is this iGuariable is like not really nice thing to do. Sometimes useful, but you really have to think about it. Is it okay? It's not okay here in this course, most definitely. So, but in your own applications, in your own private or development life, it's up to you. Yes?
What do you get rid of?
Basically, you do here the .to list exactly. So you have to finish your database operations inside the repositories. So no semi-finished or not yet executed queries shall go out of the repository. Always full data. And especially if you think back here, Pavel can speak about it, what it takes. If you do this interface and you give out the iVariable and you actually still write your database operations in some kind of controllers or business logic, you do the .where and first and whatever there. And then one beautiful day comes your boss and tells that, hey, now we change over to the Excel files or XML files in the hard disk. So please rewrite all your repositories against the Excel files on the disk. So no more database. Everything has to be on the files. Maybe it's some kind of government requirement. And basically it boils down that please implement iVariable against the comma-separated values file on the disk. Can you implement the iVariable interface?
It would be easier to change iVariable for
Yeah, but I want to get the iVariable. Since you have all over your code, you have those .where and.
They're working against the iNumerator as well, but in the memory, not in the database.
So lot of issues. And if your interface is like this, then good luck with that one. So iVariable is interface from the Microsoft, and theoretically it's implementable. So if you really will,
that's my final thesis.
yeah. Pavel has written, he's writing a final thesis about it, how to implement it against Microsoft, whatever, Windows Management Instrumentation Studio, whatever. So how to query that, how your servers are doing, and what is your hard disk temperature and stuff like that. So, so to implement this iVariable is probably something you really don't want to do on your own. So this is pretty complicated thing what to do. So the correct, or let's say the most common repository pattern tries to avoid this and does all the data operations locally and just gives out already finished data. So you have those to lists and stuff at the end. But the code initially looks like really simple. And if you look how to use it, it's really simple. So this is classical console application. You just raise up your personal repository, so you get this code, and everything kind of works nicely. But now there are several issues with it. So will we write the same interface against all our entities? So if you have like 20 or 50 or 200 different entities, you start to write initially 200 times the same repository, the same interface. And then after you have done 200 times the same interface, basically just copy and paste and change the person here to the pizza and to the user and whatever you have there. And you have to change all those person references here. Then you also have to implement this 200 times. So basically you write this pattern 200 times. Yeah. So you have 400 times basically, 200 times the interface and 200 times the repository. And then if you get this nice idea that okay, now we do the soft deletes, then you have 200 places where to update the delete method. And you basically copy paste the same code back and forth. So as typical developer, once again, if you do something twice, you already have the feeling that maybe that's not the best pattern how to approach the things. So now we need to figure out how can we reuse this kind of interface writing. If all those interfaces look exactly the same, do we have some kind of development pattern to use to avoid this repeating code? Generics. So everybody is okay with the generics?
You will be.
You will be. So now you actually will be okay with the generics. So let's jump back. So the lecture started with the generics actually. So we have used them a little bit in our own code in C# at least. I think we did use them and we spoke about them in the C# already. So but now we really need to work with them. So the simplest thing is to look at the example. So what's the idea around the generics? So the generics you do this. You write your class. You specify your generic property here. So typically it starts with capital letter T from the word type, but it doesn't have to be, and it doesn't have to be one letter. It doesn't have to be single letter. Typically you write like key and whatever. So if you need longer words, then absolutely use that. And how it actually works in the code is that when you instantiate this generic list, now you have to specify what the hell this T actually is. So now I can specify that please create me new generic list object out of this class, and please replace with T with int. And basically you can think about it like compiler will actually do search and replace for you. So compiler will make a copy of this code of this class and replace this T with this integer. And then you can call out that, hey, please make me the new object. And then you can call out again generic list from the string, and even generic list from some kind of class or object. So each time compiler makes a copy and replaces the T with whatever you have there. So this is the kind of the simplest way how to think about generics. So I don't have to write separately generic list of integers, generic list of strings, and generic list of example class, and etc. etc. So I just write one implementation like this, and then I can replace this T whatever I need to replace it with. Sometimes you need to limit what this T actually is. So this thing here says that the T can be absolutely anything. It can be a struct. It can be some kind of value type. It can be an object. It can be whatever it needs to be. So it's totally free. Typically, we don't want to allow so much freedom. We want to have some kind of constraints. What is going on? What this T actually can be? And typical constraints are those initially. So you can specify with this where sentence, where T struct. So it goes at the end here. Where something. And you can specify what the hell the T has to be. So the most common ones are that the T has to be a struct. So it has to be a value type. So all the value types are structs. All the ints and booleans and whatever, everything is struct. The other option is T has to be a class. So it has to be a reference type. So no structs anymore, no ints, just classes.
But if
It's a struct, I think. And then what you typically also need, depending what you're doing inside your generic class, is you can specify that T has, at first has to be class, so only new is on the classes, and you specify that the T, whatever the T is, has to have a parameterless constructor. So if you have to do new T in your code, and if the T is unknown type and you don't know what the constructor is there, if it has some kind of parameters, so then you cannot call the new T because you don't know the parameters. So if you go back here, if I want to do here add, I want to do like new T here, I cannot do it if for example, this example class has some kind of constructor with parameters. I cannot call it because I don't know what the hell it is. So if you want to limit that, hey, please only use this thing with parameterless constructors, then we have this keyword new. Then we have this where T, and you can set the base class name and the interface name. So you say that we did this meta fields in our domain. You can say that, hey, please only send me the objects that implement the I meta fields or I domain meta fields or whatever we named it. So you can So you can do something like this. So interface name, class name, or basically you can also reference from one generic parameter to the next. So where t is of type u, and the u is also a generic parameter. So you can do all kinds of tricks there. And there's also some more fancy ones, but typically what we need is those. It's a struct, it's a class, it has to have a parameterless constructor, and it has to be of some kind of type. So you can say that it has to be a person or iDomain object or iMeta something or whatever. So you can enforce that there is some kind of fields in this property or in this generic. And typically, logically, they are mutually exclusive. So you cannot have the struct and the class at the same time. So, and if you write new, this automatically means that the class is also there, because structs doesn't have the new operator. So kind of like logical approach. And so then we have like bunch of nice reusability out of it. Why do we do all those generics? So basically it's reusability. You don't have to write so much code, and your code can be much more expressive. So that's why we do the generics and how we do it shortly. And coming back here, so now we can write our interface like this. So now we can replace this person. We had everything, this iPerson repository or something. Now we can just write iEntity repository of type T, and now we can use this T everywhere. So all returns bunch of T's, find returns one T, update takes a parameter T, etc., etc. And now if we actually want to use it with this actual interface, now we can specify something like this: iPerson repository equals, or not equals, but is derived or implements iEntity repository against the type person. So basically now inside this iPerson repository, all the methods from here are copied into the iPerson repository, and the T is replaced with person. So we get exactly the same interface as here, but we get it without writing any actual code. Just what it is, 2 lines. Okay, 3. 1, 2, 3 lines. Nice, exactly. I will not do the sound. And if you need to overwrite something, or you need to do something more specific, you will add your custom methods here. So if you have like find person by the first name and etc., you have some kind of fancy specific methods, you will include those here. Yeah, you get those like for free. Those are like your base methods, and then you will add your custom methods you will specify here. But this is only interface. So you just write the declarations that, hey, you should have this thingy. And so let's come back. Kätlemine.
Need on siis kõrge käega tervitused küll. Proova tervitus.
Nagu see oli.
Põsemusid ja kõik muud asjad.
We need to convert all of the games from TCP to UDP to avoid handling.
Yeah, absolutely. So what I have here, let's skip those. So okay, so let's look like something more actually usable interface. So this is already a little bit better interface. So initially in this interface we have like still a bunch of like weird problems. What the hell is this? Insert or update? What the hell? How do I write code and how can I detect? Or basically you can detect, but it's really like weird that you do insert and update in one single method. And then all this iQueryable crap. Let's get rid of the iQueryable. So the repository should be like closed and only data should go out, not like unfinished SQL sentences. So a little bit better interface would be something like this. So here you can also already see like bunch of improvements. So first, the T is replaced with something more readable. that what the hell the T is. T is T entity. Then already this where that I say that this T entity has to be derived from some kind of base entity. So this is your I domain base entity or just base entity abstract class or something. So now you already know that inside your base entity you have your like .id, created at, updated at, deleted at. So you have all those like standardized fields. So if you need to do some kind of like meta operations, you can do that. And then all those all methods, which would we will change it a lot. So all those I variables are now replaced with the I enumerables. So you can return your lists or stuff like that, and you don't give out semi-finished queries. Then all those find, async, because we have those async methods. We actually still want to use that, and to keep in parallel also the not async methods. So we have a bunch of like normal methods here. So basically the add async is maybe the only one which should be removed here from initially. And also the remove both ways. You can remove via the entity or you can remove via the IDs. So a bunch of different approaches how to do it. The simplest way how to look initially, how to write this interface, how to specify what should be done is take a look at the DBZ implementation. So if you look at the DBZ, what the DBZ methods are, how the find and update and stuff is implemented there, what are the declarations. So we can basically just copy them over one by one and implement those methods really easily just by calling out the DBZ methods initially. And then we can add our own implementation. Yeah, but you don't have to do everything like that. And then like compress the implementation of it. So let's go back in the code. Where is this implementation here? So now we have one more interesting problem here. What the hell is this? Inside the repository, we make rise up a new database context. So we make a new database context inside the repository. And if you use the repository, if you use several repositories in parallel, which is kind of unavoidable. If you look at this pizza ordering, you need like all the 5 repositories what you have, or all the let's say 10 repositories more likely. So if every one of those will rise up their own database context, so then will be like a huge problem because you have like unconnected entities with each other. So like weird stuff will happen. So this is also kind of like probably a bad idea. So we need to move this one also out from here. So somewhere on top of here inside the controller, your database context is opened up, and probably inside the dependency injection, which we'll also look in details. And then you supply the already opened up the database context to the repository. So this problem is solved here. So this repository is also, if you look at here, the repository is generic. So not just the interface is generic, but the repository implementation itself is also generic. So this is not fixed. What the hell is this T entity? Is it a person? Is it a pizza? Is it a user? Is it whatever? And if you look at the constructor of the repository, it takes the database context as a parameter, even via some kind of interface. But basically, it's a DB context. So this also solves this problem that not all the repositories open up their own database connection and then give out whatever weird stuff they will give out from there. So, but if you look at the methods, those are really, really simple. Just call out the correct repository DBZ and do something. And for us, which is nice, repository DB, the DB context has a method called set, which takes the generic parameter and gives us out the correct DBZ. So we can kind of ask from the DB context that please find me a DBZ which deals with persons or which deals with pizzas. So you don't have to write it out manually what is the correct DBZ for you. You can use generics to find the correct DBZ. And if you send here the wrong entity, then of course this will be an exception. Your DB context will tell you that, hey, whatever you're asking here, temperature, it isn't the DB set in the DB context correctly. So this is kind of approach, and this is like really simple and initial approach. Everything here is not the actual methods, everything is written via the lambdas, but if you need to write like longer code, then you will definitely do the methods and do a bunch of stuff here. And how do we actually use this thing? So this one we already looked at, how you do the specific interface deriving from the IA repository. So we can derive from this interface and specify what the hell is T entity, but we can do the same with the code also. So you can derive from the AF repository and specify what the hell is this T entity. So now the T entity has the value of person, and all those methods are now copied over to the person AF repository, and T will get the T entity will get the value of person. So not just the interface declarations can be like copied over, but also the actual implementations can be copied over. So now I only have one implementation of all those methods. And if this change I want to do has to be implemented everywhere, I only have one place where to do it. So this generic pattern or using generic properties or generic parameters is really powerful and avoids a lot of code duplication. So you will write much less code. So this is the repository pattern. Now let's do it. So серьезно. Не, никакого кофе. Давай, руки в код. Начинаемся. У меня надоело все это мудра, постоянно теория. Давай больше коду. Надоело. Все, давай программируем. Right, let's get this thing done. So, do we have any questions so far? Let's see the code. Let's write the code. So, you want to see it? Okay. So, German kodanikud, kas Discord on õnnelik või? Vaikus, ühesõnaga siis on kõik mäe peal omadega. All right, so let's write the code. No. I'm losing track. I have so many solutions here that... Where is my stuff? Let's see, what was the name of it? So that one, yeah? ASP solution, okay. It should be that one. So now, bear with me, and when I create the new projects, then just believe me that those are the things we need. This is practice or hard lessons learned from the previous years. That if I started with like common project names, like initially did just a DAL, and then I had to rename it several times. And then the students totally lost track that what is where, and different lectures have like different project names everywhere. And then it was really hard to track what is going on where. So now I'm trying to name those things correctly or already from the start. So let's see what we have here initially. So we have this iDomain entity, and we have this iDomain metadata. So now the question is, do we still want to do the soft updates and deletes? No? No? Not really? Not anymore? Not really? So that depends on your business logic. Actually, do you really need it? And maybe we will enforce it on few of the entities. So let's but let's say I want to have some kind of metadata, yeah? So let's say this, let's opt out from the deleted by. And maybe do the, if you don't do the soft delete initially, let's do the track of who has changed the data latest. So we don't create new records, we just update some meta fields. So this is one-time read only, and this is changed every time when you do some kind of data operations. So this is not created, but changed by. Can be called modified, whatever you like. And let's write something like this here. No soft updates deleters initially. Initially. I still think that it's a nice idea what to implement. But let's go gradually there. And we have much things to do anyhow, so now the question is, we have the interface. This is an optional. This is an optional change. That is nice. Okay. So now we have this iDomain entity, and I can basically say that my domain entity has to implement my iDomain metadata. What you don't like? Circular reference. What the hell?
Because you're already divided from it.
No, I'm deriving from the iDomain entity.
The metadata is derived from iDomain.
Was it? Really? Oh yeah, okay, it is. So let's say, let's maybe rename it a little bit better. So this is iDomain, let's say something base entity. Let me think now. How it should be renamed.
Just remove
Look.
from there.
No. This is like now we need to do architectural decisions here. So I have like different approaches. Should it be like this? That we have ID, then we have the meta, and then we have the domain. Will it be the meta, ID, domain? Will it be the ID, meta, base domain? Will it be ID, meta, so many complicated decisions today. So what should be derived from what? Is the first one ID in the line, and then the meta, and then the domain, or is it meta, ID, domain in that order, or is it some kind of base from this and that?
I think this is a better one.
So there is like different approaches. So the first question we need to think about it from the architectural viewpoint is, will we have some entities without the ID?
It's possible.
theoretically it's possible, but
Yes.
like, but
We can take a picture.
absolutely. So next question is, will we have some entities without the meta?
Yeah,
This is like more probable, yeah. So this means that if we will have some entities without the meta, then this is off and this is off automatically. More or less, because we want to make this an optional here. So okay, let's say this is mandatory, this is optional, yeah. So it can go both ways. So this means that we need to do, probably this is bad to do add them singly. So we need to do like we need to have three options. Either it's just an ID, or then it's the other one is ID with the meta. So basically we have two kinds of objects. It's a domain with an ID and domain with the ID and meta together, yeah? So basically we have those two options kind of running around. So now the question is, shall we glue those IDs and metas together into one interface? Probably makes life a little bit easier on the long run. So that's my like architectural decision. So this stays as it is. So then the metadata just specifies just the plain metadata. So let's rename this one also. Let's iDomain. So this is probably just the base. So this is the most base unit there is. And now we need to do this this kind of thing, or let's say this one, those two glued together. So let's do a new interface. iDomain. Let's say it's iDomain entity. Now, okay, I need to rename the file first. So that one will derive from the, and let's do the generic thingy. So what will be our primary key type? Like GUID is like specific to the only few database implementations. String is kind of like more universal. Yeah, of course. And it's not that hard to change actually around, so we can go whichever way we want to. Let's vote. What do you want? Int? Int is also okay. It's up to you totally. So you can. It's really easy to change around.
It's just the default.
Yeah. So which one will be the default? The string is in that sense like the hardest thing to do because you have to initialize it manually.
Yeah.
That way the GUID and int are kind of like database takes care of those. But if we want to do the soft update, the delete later on, then the auto incremented int is kind of not the thing to do. So okay, let's do the GUID. So at least Microsoft SQL is supporting the GUID out of the box. So GUID it is. So this one has to implement our iDomain base entity with the same k, and mitte vastupidi. ei, ma läksin nagu siia. Ma teen selle kokku. Mul on ID eraldi, mul on meta eraldi ja mul on see nagu kokku.
ID sul on iDomain entities ja base'is.
Ei ole iDomain base entity, ära nimes ära vaata. See on that's very common here. And now what is the limit on the TK? What can the TK be? So let's go back to the base entity here. So what is mandatory on the primary key? Can it be an object? Really? Like, I mean, like theoretically maybe, but like practically, how do you store the object as a primary key in the database? Probably no. Let's say no. Struct it is, yeah. So what else? Does it have to be sortable? No, that's like different. That's already database-like constraint. Unique is business. Basically, unique is a business logic constraint. So how do you enforce that it is unique? How do you enforce that stuff is unique? What do you need for it? If I give you two objects, what do you need to do with two objects to decide that they are unique or not? That's why we have this iComparable here. So there is a special interface called iComparable, which tells you that, hey, this thingy, if you take two of those, there has to be a some kind of equality method between them. And so we decided to go for the GUIDs. So it has to be a struct. So this means that this is a simple field in the database, and it has to be comparable. So this means that, okay, I can't write the code in the interface, but we can see what the iComparable means actually. So it has to be a struct and iComparable. Now the problem is, not the problem that, but how do you write this code, is that if you specify constraints on the generics, you have to use the same constraints everywhere. So this is kind of the base constraints. You can add the new ones here, additional ones if you want to. But we started from this base entity with the IDs. So everywhere where you derive from the iDomain base entity, this TK has to be a correct type. It has to match with this. So if you do here, if you derive from the iDomain base entity and you send the same TK here, you have to be clear that what the TK has to be before you can send it forward. So you can write some kind of like something which you really cannot write here. It cannot be new. So you can write additional thingies here. So let's say for example, maybe iClonable. So this is totally okay. So you can add additional limits, but those initial limits always have to be here. So you cannot allow wider types than the smallest one in the bottom. So okay, now we have specified our domain entities. So,
but one question: the idea with the limitations with where the TK is struct or iComparable, are they inclusive, or let's say if I implement one type, it also has to have the properties of, let's say, for struct or iComparable?
yeah, I mean, you have to do both. Struct means that it cannot be an object.
Yes.
And IComparable means that there has to be some kind of whatever the IComparable interface is specifying.
Yeah.
There has to be some methods actually inside the struct, which allows to compare one object to the other one. So basically, it means that there has to be kind of method like equals, bigger than, or not equals, or stuff like that.
So the idea is the more I put down the types for the TP,
Yep.
the harder it is to implement it in anywhere.
Yep. Or yes. So the stricter it is, not that it's harder to implement, but
yes.
the stricter it is.
Limits the where can we
Limits what you can use as a TK actually.
Yeah, okay, cool.
So now it's limited only to struct, which means that you cannot write an object here, like that just. So now we have our stuff. So okay, now let's start to write our interface for the repositories. So let's make a directory here, and once again, repository yes. Believe me, what I'm doing, I have tried it several times. So basically, we only have this is the contracts DAL base. So this is the base interfaces. So the base interfaces for domain objects and base interfaces for the repositories and what else we will have. So, but we will try to repeat the same structure of catalogs everywhere. So when we get to the DAL app EF, where we actually have to implement those repositories, we do the same catalog structure. And there we have all your 50 repositories. And you don't want to keep them all in the same directory, like in the root directory. So that's why we separate those inside like normal directories. So let's do the repository. So this is our some kind of. Hey, I want to write the code. Oh, okay. This is our I-base repository. And it's not actually a class, it's an interface. What the hell? Okay, so let's write the stuff. So first, it's a generic. We don't specify what the hell is coming here. So it's some kind of T entity. So what limits are there on the T entity? Really? Like only integers? So your database table is made out of integers? So actually, can it be a struct? Basically, we are speaking about TB-sets. Can you make TB-set out of integer?
No.
No, so basically it has to be a class, yeah?
Yes.
So we can say that it is a class. Does it have to be a new? So does there need to be a parameterless constructor inside our domain objects?
We not have the possibility to construct the classes then, so I think we can't do it.
No, I mean, actually, how does let's think what the entity framework needs to do. When you query the object from the database, you get bunch of data in some kind of array, and now you start to map this array into the objects, which basically means that it needs to create an object and then copy all the properties over. The same as when you bind the properties in the actions.
This way we can integrate.
Basically, I think the new is more or less mandatory there.
Yes.
So we can keep it here to say that it has to have a parameterless constructor. Doesn't have to be default constructor. You can write your own parameterless there, but there has to be a parameterless, either default or your own custom one. What else? Are there any more limits? Yeah, we can. So, what should it be derived from? So maybe the I domain, maybe the base entity. Something like this.
But isn't the entity one with ID and data, but the common one, and the base entity is
That depends. Do we want to do we need to specify here the both? I mean, do we want to specify the common interface here with the metadata? Is everything with the metadata? No. If we don't deal with the metadata here directly, if you don't do any kind of like created at and updated at operations here, then you maybe don't need the metadata thingy. Maybe you need to do like two repository interfaces, like iBase repository, then do like iBase repository with meta updates. So there's like different approaches what to take. So, but we can go in that sense that that let's say that it has to be with everything. So this base entity only specifies the ID, but domain entity specifies that there has to be a meta also. So if you do it with the meta immediately, then the question is, for example, if you want to do those user tables, the user tables doesn't have the meta fields; they only have the ID. So it's so and so. But theoretically, we don't deal with the user tables directly. So user tables are dealt by the user manager and role manager, stuff like that. So we can specify the whatever it was called, domain entity. Yeah? So like this. And since we already started with the whole generic lifecycle, we have the key. So this is the domain entity out of key. Key has to have the same limits. So it was what struct and comparable. And this one specifies that this is from the guide. And this is also the entity. Can I specify it like this? Okay, item entity. Yeah, no, T entity doesn't have. Yeah, should be like this. And so now we need to specify a bunch of methods. So, what will we actually do here? So we have all those crude methods we need to implement. So, bunch of crudes we need to implement. So we can go back to the slides. So what do we need? All async, stuff like that.
Let's change all again and add parameter. Something parameter we can add this expression from.
It's not so easy to implement.
It's very easy to implement, just one row.
I mean, to implement it actually against your Excel file.
It is a nullable parameter, and in your in Excel file it will be done against nullable. It's really easy.
Yeah. Okay. We can do it. Absolutely. Yeah, absolutely.
Yes.
So it's a enumerable of something which we return. So we return the T entity. And okay, I will stick initially to here, and let's replace let's do the above thingy on the go. So then we have now we have like several options what to do. So let's write first those non-async versions of everything. So we have the all, and then we have the find, which takes the params, so object of something called ID.
Object or we have specified
This means that this this is your primary key fields, your primary key values.
but we are specified here that we have just one and it is still key.
Yep.
There is no point to have this.
Can be complicated. So if you think about this soft update and delete problem, then the question is that if you have their primary keys a little bit differently, no, not necessarily. This is just an ID on our ID type, not necessarily primary key, definitely. We can change the name to the something like tuch ID. Depends how we do the primary keys, finally. But this is what entity framework wants as a parameter. So this is classical entity framework find method parameters.
So I understood that one in the find method can be a composite one?
Yes, yes, that's the idea. You don't send like several IDs here. What you're sending here are your primary key pieces, so to speak. If you only have one single field, then this is one single field. If you have like composite, then you will send your ID, comma, deleted at, or the primary key, comma, deleted at, or whatever your primary key is made out of. And the entity framework will automatically match those to the correct thingies. So, but they have to be in the correct order. So, like ID first and deleted at the second position. So what else? So then we add the add. And add, I think, also returns the entity actually. Then we have the update, which also returns the something. The issue is that this will return you the tracked entity. So this is your actual object initially, without any kind of tracking in the database. And then you add or update something, then the entity framework will start to track it. So if you modify something inside your entity, the changes will automatically be reflected in the database when you do the save changes. You don't do that. You don't need to call the update method several times. Or even if you do this find, if you do this find, and you get some kind of entity out of it, so you get the result from the database, it's initially tracked, which means that if you change something in the result value and do the save changes, then it automatically updates in the database. So entity framework keeps track of the object in memory. And then we have the remove, which doesn't return anything. No, it doesn't return anything, I think. Int you will get when you do the save changes, then you get how many operations did you do. And then we also can do the remove by the key. So that takes the same object, same parameter. So list of possible key, composite key values, if you have those. So basically, this is it. So those are the methods that you have to have in the repository.
Yes.
So now we can think that maybe initially we also need to have this, we can write it here. So that one will be the int save changes. Maybe we also do that one. But now we have all those async methods, which we actually do need. So nicely, if you do things nicely, then your code should be async. So you call out to the database that please do something, and the database will take some time to do the stuff. Meanwhile, you want to release the resources and take the next request from the web and serve the next client. So this means that the async pattern is kind of like obvious thing to use out of the box. So if you scaffold your controllers, even then you see that everything was async. So and all the asyncs were used. So basically we need to add also the async methods. Now the question is, how do we do the async methods? That shall it be together all in one interface? Do we make like the same thing we did here with the ID and meta and glue them together? So we can do like several different ways. But let's start with something simple. So let's just copy them around. So now we have this task. And then it's async. Find is also async. So this is task entity find async. Add also has an async version, but this is only used when you actually have some kind of database operation connected with it. So you never ever call add async just like that, because it only happens in the memory. There's nothing called into the database normally, and so there's no point to do add async. It just adds overhead. So add async is only then when you have some kind of weird primary key which gets generated, or if you have some kind of store procedure behind it, and then you can call out to the database to actually do the add some kind of. So this is only for the special cases. So update the same way. This happens purely in memory, and remove is also purely database operation. So purely memory operation. Nothing happens in the database out of the box. You have to call the save changes. It just puts the flag in the memory that, hey, this thing should now be deleted in the future. And the save changes is also async. So this is also a task. Save changes async. All right. This seems to be it, what we need to do. Not that much, actually. Kind of this save changes here is kind of the suspect a little bit, because this is not actually a repository kind of like thingy. This is the whole data store concept. So we will speak about it. So when we speak about unit of the work, what happens there, then we will probably remove those save changes from here and do it globally. But initially we can think about them like here. So let them be here initially. So this is our interface. Now we need to implement this thing. Oh no. Let's see, you want to do
just write additional one, then we can go if it's not visible. Expression, found.
Expression. It's in generic, huh?
Found it says on the entity and to
Pool.
bool.
And
Yeah, predicate word of node. This equals now. It's just then all is not needed because it is not specified.
yeah. Douglas, let me think now. What do you want to actually do with that one? Expression monk. Let's go back here. So
Then in implementation you can check is it null or not, and if it is not, then you will add .where and just pass this parameter to where to filter out.
I'm really unhappy about it.
Why?
Because this means that you let database queries slip out of the repository once again. You start to specify your what do you want to do. You start to specify outside the repositories.
No, it's just a filter. You can apply it to an enumerable.
No, doesn't matter. Your method is a suspect.
But this is the
This is a really suspect.
filter.
Yeah, I know.
And
So you want to
you
say
will
that?
not, you will not have equatable like. It's
So you
not-
want to do
it's
something
not-
like this?
Yeah.
Okay, let's see.
Right. You can keep it.
So we want to have this one. So something like this. So let's try it. I think it's a suspect. I do not like the idea because it's almost the same as letting the ig variable out of the database.
No, but the equatable is
No, I know what I mean, but
difficult to implement, but this
this is
is really
not really easy to implement.
why you just need to pass one variable to the next method.
We'll see. Let's say you will change the database to the REST controllers.
You should not pass it until then, but you can use it in your service. Just to restart.
No, I mean here. Let's replace the data access with the REST controllers. It's not the database anymore. So then I need to somehow parse this expression tree to the pieces.
No, you don't need to parse it. You
What?
can just really ask everything. And,
Go to hell.
and filter and then this is the easiest way. Or you can go to this expression and take whatever you want.
So
It's just additional like option.
how easy it actually is. So because you can write like any predicate here. So then I need to like parse your any predicate
If you want to
and
pass
match it,
any, then
and
it's
then
not
it match
really
it and then match it somehow against the REST controller queries somehow.
But if you look at this code, you can use it internally. If you will add any additional
Let's copy it.
methods.
I have an idea. Let's discuss it in coffee break. Then we come to a solution and we say that the idea was like bad.
No. The idea
Or good.
is kind of okay. My concept is this. My idea, or my problem with it, is basically the same problem as with the ig variables.
Took pictures, uploaded them.
So there is we have this a repo which goes against DBZ, yeah,
Yeah.
like this. And if you do this repo with some kind of predicate, you can do the DBZ basically with the same predicate. So that's kind of like easy and obvious thing, yeah. Now my question is, now the nice boss comes and says to you, and this has to be a REST. So we'll do a web queries. So the same thing we are doing here. You're specifying your REST, you're writing your own REST controllers. So now the question is that we have the repo with the predicate. So let's say the predicate was, we have the, let's say the person dot first name contains whatever. Okay, it's my last name. And then the person dot age is bigger than 40. So we get like this predicate. And now out of this predicate, of this condition, we have to generate our specific URL.
Yeah, but this is instead of all. There you don't have any. And this is only the way it will filter in the memory.
Yeah, but if you say that's filtered in the memory, then you go against your person's database, ask for all the 20 million records
No.
over the REST controller, copy them all of the.
In case of DBSet, it will be done in.
In case of DBSet, yeah. In case of DBSet, it's okay.
This is just adding possibility.
Yeah, but if you write it like this, if you give out the predicate, possibility to write the predicate, then you have to be totally sure the same way as with the IQ variable that you're able to implement it against any data source. Are you able to implement it against any data source?
It depends on data source.
Yeah? REST controllers, comma separated value files, whatever. REST controllers.
Comma separated value
Yeah.
files, it will
Yeah,
go
you can copy
anyway to memory.
Yeah, copy it to the memory anyway. But
Then
not
we'll
not necessarily actually. You will go over line by line and collect out correct data and leave the rest behind. You don't copy everything to memory.
The line by line is already quite calculable, and then you can just pass this.
Yeah, but then you have to parse this. You have to parse it to the pieces yourself, more or less. But let's take the rest. You want to get some kind of URI slash like persons, something like boom. Name equals something and age equals something. So you have like bunch of different parameters you can send.
If you got this task, then you need to implement.
Yes. Which means that
But you will have.
let's leave it to the Pavel. Pavel happily has done this subject already. So I'm kind of skeptical about it that I really want to implement an IQ variable or predicate expression against any data source there is.
Skips is spread like the coronavirus.
Yeah, I'm a skeptical. Let's take the easy. Let's take the easy
I just.
E- easy approach. What break?
Yeah, that.
You will have a long break, no school for the till the spring.
For a coffee.
Okay. So we are almost there. So let's write there something like this. Do would be nice.
Anyway, it is by default now, and it will work as always.
Yeah, but if you already specified like this, then somebody else will actually want to use them, and is really mad at why I'm specifying the predicate and nothing happens. So we'll see. Let's see. Let's start without the predicates. Let's keep everything as simple as possible initially, because I don't want to go there the same way as I don't want to do initially. We do the soft delete in the save changes method. So where when you need to reflect all over your structure and find out what is what and what is connected to what kind of like semi-automatically. So it's not the easiest thing to do out of the box. So okay, now we need to implement this interface. What the heck is going on? With my thingy here. Come back. So now, where will we implement it? So this DAL app EF is already a specific data access layer for our own application. So this is not universal. This speaks about our pizzas and orders and stuff like that. So if we want to do it correctly, we need one more project. So at the end of the course, we will separate those thingies into a new solution and push them actually to NuGet, so they are reusable automatically. So, but initially, let's start from here. So let's add a new solution, new project.
You have this double.
No. This is really common DAL base, which doesn't speak anything about database technology we're using. Just now we are implementing against the identity framework. So this is specific that this is implementation against the entity framework. And we don't have anything here initially, so we can just kill that one. And then let's add the same folder, which is called what? Repositories. So we need to do the base repository, exactly. The class. All right. So this will implement our iBase something. So what was our iBase repository? So iBase repository speaks about some kind of T entity. So it does not have an final implementation, it's a generic. So our base repository does the same thing. So it's a T entity. And it just sends this T entity here. And the T entity has a bunch of limitations. And we can just add it automatically. So we get all the limits we need to get. And if you really want to be nice, then we will do the same pattern as we did previously. So this is actually T entity out of DK. It's a iBase repository. Which one did we have there? T entity, and did we have one with TK also? So this TK will go there. So we have those limits. So this will be also the TK here. Implement missing members. Yep, absolutely. So let's see, and this one will be derived from the base repository. Yeah, who the hell? What did you do now? Command copying. With yep, the T entity and with the GUID. And we need and the limitations we do need. So look at this. So theoretically we have now why do it like this? This is the same way as we did with the identity user. So we have the default implementation which goes against the GUID, but if you really want to, you can use the base repository with all the generic options, and then you can specify your own key type. So if you want to do the ints or strings or whatever you need to do, then it's totally okay. And now we need to implement those methods. So basically implement missing members, all of those. So just start to implement those. So there's a bunch of methods to implement. So what do we now actually need? How to implement those? So the first thing I need is this dbset. So I have now this t entity, and I know that inside my db context there should be a dbset for the t entity. So basically I need my db context, and I need my dbset from inside this db context. So where can I get this db context now? One way would we write something really like bad, is like var context equals something here, and to initialize the context here inside the repository. This would be like really bad. Like don't do this. So the only way what we can do is let's write a constructor. So somebody from the outside should give us the necessary db context. So let's write the constructor and say that we have some kind of let's think what it should be. db context. db context. Now we need to get the db context. What the hell is db context? Yeah, entity framework it is. Okay. So let's save the db context to somewhere. So we need to do something which is probably protected, just in case. So what was protected? Yes, the child of the base repository, and we definitely have a bunch of childs. The childs can also access this property. So if you do the private, then it's only inside this one single class. But if you want to allow the childs also to access, but not allow access from the outside. So it's a hidden field. It's a kind of private, but it's not private among your family, so to speak. It's family shared there. It's like toilet inside your house. Your kids also can visit it. Typically, yes. I don't know how your household is working, but so something like this.
No, it's protected, not private.
I mean, it's protected.
Yeah, but naming was protected.
Oh yeah, naming is not that, and even I think naming should be with capital letters in case of the protected. And I need to initialize field from the constructor. Okay. And now the next thing I need is also protected is the dbset out of my diff entity. And this will be my dbset. So now the problem is, at least a little bit, that is this the best name? Kind of like db context everywhere, kind of gets annoying.
Do just one.
I will do like repo db context and repo dbset like this. Then I know what I'm speaking about. So this is db context inside the repository. Okay, now I need to dig out the dbset from inside the repo db context. So, but this was kind of easy because there was a method for it. So I can say something like this initially is a repo db context, and there is a set method. So this is kind of like a find method, and I can use the t entity here.
So we are trying
yeah, whatever is this T entity, is the person, the pizza, the toppings, the order, whatever it is, we are asking from the DB context we received here from the outside that please give me the DB set from this T entity. And maybe this repository DB set, probably it can be null, can be failed. And I think that it will not throw them exception if it fails. It will just return null in case it doesn't find the actual DB set. So maybe it will be nice to do some kind of control here, just in case, that if this repo DB set equals null, then just let's throw.
You can just on previous row type 2 question marks and throw.
Yeah, absolutely. But let's write it first like long way. This YouTube broadcast is making my computer slow as hell. I'm like really annoyed with it. Like I'm writing and it doesn't work as I want.
You need a new method.
No, absolutely.
How long is the delay between echo?
I don't know. Open up the echo and look at it.
So maybe we drop the user.
Yeah, I think argument all exception.
10 seconds for echo. So drop the user.
So throw new argument null exception.
Name of different.
Yeah, something like this. Name of. No. I don't think so. Maybe. Let's see what it does. We can try it out. We need probably something like we need to do a reflection here actually, because I think this name of T entity will just give a T entity. But I actually want to get what is the actual base type you're asking for. So probably I need to do some kind of reflection.
Then you can do type of type entity dot type name.
Yeah, because type of is actually a little bit better, and then we can ask.
Just full name will return.
Full name is maybe not the best. Let's see what else is there. Like name. Yeah, something like this. Was not found as DB set. Something like this. So if you didn't find the DB set, then just let's throw it. Okay, now we need to implement all those things. So this is like fairly simple and straightforward. So return. This is our repository DB set. Toolist. And so there is no toolist. Okay, it needs to import. All async. Return, await. So this has to be async. So that was mandatory in case of the entity framework, if you remember back, that you cannot run several queries in parallel in entity framework, async queries, because this will do a lot of confusion, what is already received and what is not. So you have to always await your database operations. So in case of entity framework, don't return unfinished tasks, only return already finished stuff. So basically always use the await, unless you really carefully think through what you are doing. So this basically returns the same thing. Repo DB set. Toolist async. Find. Return. Repo DB set. Dot find ID. Find async. Return. Await. Repo DB set. Dot find async. ID. and this has to be an async. Add, return, repo-db-set, .add. So what now? Oh, okay, and this one has to be, we get this entity out from here. So add will return you this entity entry, and from this entity entry you can get the actual entity. So we have to check actually what happens with the IDs. So if you create a new object, the ID will be, let's speak about the integer primary keys. So, yeah, but just think about the primary keys. So if you create a new object in memory, the value for the ID will be what? 0. Default value, it's an integer, eh? Default value. If you don't set the value manually, somehow it's a 0. So now when you add it to the entity framework, so you add and to some kind of DB set and it starts to track it, then it used to be, we have to check it what it's now, then it used to be that it the first add got the minus maxint as the value for the ID. And then when you add the next one, then it was minus maxint plus 1, and so it goes on, plus 1, plus 1, plus 1, plus 1. And then when you do the save changes, then you get the actual IDs, so what the database had as a positive numbers.
But then you can have here just a void and still not return anything.
Yeah, but we typically need to track the entity. We need to
Yeah,
see.
but it will change your input.
Mhm. That's the idea.
You need to reassign it.
Sometimes you need, you can totally ignore it. You can ignore it, but sometimes you need it. We'll see. Let's say this return here is a painful lesson learned during my development career that you actually need it.
Then you can return really this entity as it is returning.
Theoretically, yeah, but I don't really want to do it because that will leak the implementation of DBZ. So I want to keep it distinct pure. So return repo dbz.update. How did I get so many parentheses? Entity.entity. Remove. Okay, remove was there as it is, I think. Return.
Return.
Yeah, there is no return. I'm sorry. Kind of used it. No, remove has the return type.
It may be fast, but you have void.
Yeah, I have void. Yeah. So let's add. Let's go back and change it. Where is my IE-based repository? So remove has also returns the T entity. So let's stick to it. No, remove doesn't have that. So it's a T entity. Probably nothing. But let's just skip to the stick to the whatever the thing is doing. So now this one is more complex a little bit. There is no method remove by the ID in the DB set. No? Exactly. We need to do the find first and then do the remove. So and that is already nice to do via our own methods. So we can do something like this. That is actually return, remove, find, ID. And save changes, we'll just go return to the report db context dot save changes. So this is async. And just copy this line. Return, await, save changes, async. Hurrah! It's done. We have written our base repository. What to complain here? Okay, it has to complain because this one now specifies a constructor, and that one doesn't have a constructor. So this one just has to call the base constructor here and forward this DB context. So now we have our repository. So this is the base repository. And now we can actually go here and start to implement our stuff. So first, what do we need? Is a bunch of interfaces.
But let's implement after the coffee.
We have like 37 minutes. Okay, let's take a coffee break and let's eat something quickly. And so then we can continue.
Pizza.
Pizza, yeah. So let's take like 15-minute break. So let's continue in what, 40?
Ja 2 nädalat järjest.
Whatever else is implemented in my lab is doing it well, you know.
I thought they were gonna do something because the lecture is super silent right now. No one says anything.
I just hope that they will do something. Because they cannot, I think they want to start everything. But if you do something with classes that require houses for the universe, or the same if you want to submit to the semester and finish to the next, which is also very cheap, or you can jump to something new.
If they close down the university media to stop all the courses, they would need to.
I mean, probably for some subjects it would be So yeah, today I'm going to invite my friends down. I know this week is not very expensive, but we're probably because of the champagne factory. This range includes the first working on. You will go to the factory and let the French and the employer like 10 years of work or something. So it's like really classic of also thing. If you study coffee this week, which is yeah, I'm doing the clothes there, which is like this really rich. Champagne with no friends and yeah, good for them.
Maybe I didn't have to push it in, but more than like 20 minutes maybe. And everything is recorded, so you can watch it anytime. Nii. So let's continue. No, should be. So now we have the base implementation, generic one, and now we need real ones. So this del app.ef should do the real ones. So let's add the folder here for it. So it's repositories. And now, even before we can implement anything, we need to think about our interfaces. So what shall be in our repositories? Can't just write any generic thingy. So where can we keep our app-specific repositories? What is going on there? So we need also do something like this. We have this contracts.dal base, and now we need something for our own application. So what shall our data access layer look like? So this is what I as architect typically have to write to the junior developers. So I'm not writing a code, I'm just writing a bunch of interfaces. And somebody has to go and fulfill those. So let's write those interfaces. Add a new project. So we just love new projects. The more the better. So it's what the hell is doing? So it's contracts.
Class library also that would be.
Yeah, class library. No, absolutely. Go to hell. Contracts. Dal. Yeah, and standard. Contracts Dal app. And it's net standard 2.1. And it's not the Dal app EF, because this speaks about what the data access layer should look like, generally speaking, without any specific implementation. We are just thinking how the data access should be, and the entity framework is just a detail of the implementation somewhere. So it doesn't concern the contracts. So when we describe the shape of the things. So let's open it up. So this one we don't need. And we just need to do the same thing: folders, directory, repositories. The more the better. So what do we have in the domain? Because now this is already our app specific. So this is about our own app. So we have what? Author, a post, whatever we have here. So let's look at something. Category. Where does it start from? From author, I think. Okay, let's do them one by one. So add a new interface. So this is now already a specific thing for our own application. So now we have already fixed everything. This should be, for example, author repository. And it's an interface. So this should be derived from the base repository, which you need to import from somewhere. And that entity is this author, which one I need to reference from the domain. And it even went okay, because probably author implements whatever needs to be implemented. Yep, domain entity metadata is, and what the hell is domain entity metadata? Let's see, what is a domain entity metadata? It implements both domain entity and domain entity metadata, and domain entity is something like this. So this is bad. So now we have the GUID, not string anymore. Yeah? So this has to be a GUID, and we don't need this part anymore here. And we don't need the max length on the GUID. And this domain entity even just speaks about okay, this is the complete thing already. So this is with the metadata and everything. So we need, the first one was base entity. So this is domain base entity, I think. Yep. So we can fix those. Domain, let's say this is a domain base entity. Okay. This is the domain entity metadata. We can do them one by one. It needs some more stuff. And those deleted by and deleted at we just now removed. And probably we can even set change that as data now. So initially it's equal to the created at. What else does it complain about? Waiting for intention actions. What the hell? What else do you need? No, this should be it, I think. Yeah, it's happy now. But since we changed that one, let's rename the file. And now we need one shared domain entity. So we have those two base entities. One is just with metadata. One is just with ID. And now we need the shared common one. The problem with the shared common one is that we don't have the diamond inheritance. So we cannot derive at the two abstract classes at the same time. So we can derive at one of them and then add the interface for the other one and then implement those methods manually. So let's add a new class. So this is our domain entity. But we have the interface for it. So this was our I domain entity. And now we can look what is missing. We have a bunch of those things. That's what the interface says that there has to be. So now we can import some of those via the inheritance. So we can say something like that it's a, let's say, domain base entity, like this. But I cannot add the second one here. You cannot derive from two classes at the same time. So now I still have to implement the rest of the stuff. Or the other way is to do implement everything here. So maybe that will be even like more better choice. So let's not import anything, and let's just implement everything.
Which is faster? Which is better?
No, in the fastness there is no difference. The problem is that now I have several implementations of the same thing basically. But this is kind of base. This is like the shared class. So I will do a NuGet library out of it. So then you can choose which interface or which implementation do you actually like take from. So because you will not change this a lot, you will do it once in your lifetime basically. If it's done well, then you can keep it basically forever and not change anything there. So the only thing I would say here is something like virtual everywhere, so you can overwrite anything.
And you still can add things if you need that?
Yeah, absolutely. So everything should be virtual. Yeah, those also, just in case. Maybe you need to overwrite them somehow to do better implementation somewhere. So now we have like 3 possibilities also here, the same as we have in the contracts. We repeat the same pattern here. So since we had like 3 separate interfaces, we did 3 separate implementations of those interfaces. So and in our own application we choose one of those, whichever. Okay, you can mix them also, but theoretically you will choose one and
So either metadata or metadata and ID or
just ID. Either just ID with the metadata. basically this is kind of like pointless in the sense of entity framework. So since there is no primary key. But if you do the primary key somehow differently externally maybe, or you have your own primary keys defined separately, you don't do them via the interfaces, then you can just include this iDomain entity metadata or this implementation of those, and then it's okay already. So, but those are like nice base classes to derive from. All right, and now we can see in our repositories. So now it complains that the author must be convertible to something, yeah? So it has to be iDomain entity. So let's see what our author is. So that one definitely doesn't go, because there is no ID here. So I need this domain entity. And now I'm happy here. So everything matches together. And basically I don't want to write anything here. Like add your custom methods here. Author specific, like find author by amount of books published or whatever you need to do. So if you have something specific. And now I can go and implement this interface. So I can go to the, where's my tal app.ef, and now I can do actually repository out of it. Add class. So this is now a real author repository, which implements the iAuthor repository. Which I need to import from somewhere as soon as my writer will figure it out, because everything is really slow. Waiting for actions. Hey, what the hell are you doing? Analyzing the file. Now it got it. So now it should give me a bunch of methods missing, hopefully. Since there is an I-based repository, yep. So, and it's slow. It's so slow. It's still indexing and analyzing my files. If you look at here, bottom, yeah.
200.
So it's still scanning something. Because everything is also broken down the line. Theoretically, I could do this and unload the project. Should be much faster. Hopefully. Kind of remove it. So don't remove it from the solution. Don't delete it from the disk, but just temporarily remove it from the solution. So since I'm not fixing the web app yet, I'm just working around it in the data access layer. So there's no point of keeping it here, because it constantly tries to analyze it. Everything I do, everything is now broken because I'm doing a bunch of changes everywhere. The domain is different. So now my controllers are bad.
Here's the whole project.
Yeah, so it makes it a little bit easier. Yeah, then we can load it again, yeah. And I don't have to do it like add existing item, because it's still referenced here. I can just do the right click and reload the project. And then it's added back to the solution. No, it continues automatically. It switches to the new one. There's like few seconds pause and then it goes on. But I'm kind of, what the hell is going on here? Because my author repository has a I-based repository, and my I-based repository is derived from nothing. That's the problem. Like this. That's the issue here. So base repository should include this generic one into it with correct generic parameters. And now I should probably get some kind of errors here. No, not here. Here. Yep. And now you should, if I look here, just a second. Now I need to implement all those methods that the interface tells me. But I know that I have already done those, like universally. So the one you asked is not here, but I forget this this I-based repository against the T entity was totally empty. It just told that entity has to be something, but nothing else. Just formatted the code. So now I need to implement all those missing methods, but those are kind of like easy to do because I have this base repository. Base repository. And I can just send the author there. And I need the reference to the author also. And now I only have constructor, what I need. All the rest of the methods I get from the base repository. So that we implemented first, manually, line by line. So basically all this code is now included into my person repository, or what author repository, just with the T entities replaced with author everywhere. So now you have this generics and interfaces galore. Interfaces and generics everywhere. And this will be your life from now on forwards. This is basically how object-oriented programming is done. Everything is done via the interfaces. You will never ever use fixed specific types. Really, really rarely. All the unit testing, mocking, everything needs interfaces because you need to switch around the implementations. Just now I want to test with real person, with a real author, then I want to test with some kind of fake generated author. How can I generate the author? I need some kind of specification for it, how to generate the fake testable author. And then that's where the interface is coming from. So interfaces are used really, really, really widely. There's no
like understanding.
Yes.
So like for example, this I-based repository, we create like two duplicates, like one from T entity and the second one from T entity and TP combined. Like why do we do both?
Because maybe you want to change the key around. So if you want to change the key type, and basically you cannot touch these base interfaces anymore. So those are think of those that you are the Microsoft. You will write the interfaces that will be uploaded to the NuGet. Those are NuGet packages actually, down the line. And you really, really don't want to touch them anymore. Those has to be universal. So if you fix the T key to some kind of type out of the box, and you don't give the end user or end programmer any kind of like ability to change the key, what will you do? I mean, what will the end user do? Think about app user we did, which was derived from the identity user. So if the only implementation would be the identity user with the string as a primary key, then you're basically stuck with it. So that's why they provide two implementations of it, like one specific one with the string as a primary key type, and the other one with the generic that, hey, if you really want to, then supply your own. So we have written those contracts, the base contracts, like two ways. One is the specific one with the GUID, and the other one is with the choose your own T key, just supply me something, and we have written what the TK has to be. It has to be a struct, etc., etc., etc. It has to be comparable and whatever can you think of. So and then you can then supply your own thingy. For example, here, let's start from the, if you really want to do it. Where is our contract style app? Here. Let's say you don't want to do the repository with the GUID as the main type. So then you have this, and you can write this. Now you have supplied a new key type. Now you're not using the, if you go and look at the IE-based repository, now you're not using this one anymore, yeah? This is not referenced. You're referencing this one. And what we got now, why we get the error, is that this int gives the problem here. Why does it give it the problem here? Now let's see. Okay, TK is okay here. T entity has to be IE domain entity against the TK. So against the TK, so the TK is, the TK is now int. No. Learn to read those, analyze those.
Yeah.
We want to derive or base our new repository from the IE-based repository against the author and int. Initially, I have absolutely no idea what those mean here. Kind of, if I look at this, what the hell is this? Let's go look at the IE-based repository. IE-based repository says, okay, the T entity will be the author, the T key will be int. Yeah, okay. The T entity has to be, let's start with the TK. The TK has to be a struct. Is an int a struct?
Yes.
Yes, it is. Is int I comparable? Probably is. Okay, TK is okay. Let's look at T entity. T entity has to be a class. Is author a class? Yes. Is author implementing I domain entity? Yes. Yes. Is author implementing I domain entity against int?
No.
No? Let's go and check. What's the problem? Let's go here. No, doesn't understand anything. It's from the domain entity. Let's go look at the domain entity. The domain entity is from the I domain entity. Let's go look at the I domain entity. I domain entity is against the GUID. So we have found our conflict. So those types now, although there are several steps you have to look at, but at the end of the line there is a mismatch. We cannot use it like this. So if you want to do it differently, then you either now have to overwrite the author, or do the author also with a generic implementation like this, but then you have to write it. The other way is go and fix what the hell the author is. So if you want to really fix it, then you have to go here, then you have to go to the domain entity. Domain entity is derived from the I domain entity. So probably we also, since this is a generic implementation, let's say I domain entity is in our DAL base. So if you want to do that one here correctly, then you will probably also need to do this. Let's make a copy out of it. Once we already started on the path of generics. So this one has to be also with the TK. And then this will be type of TK. And then this will be of also of the TK. And then we need limitations. No see on ikka nii aeglane praegust, et silma nägemine läheb ära. Which means that this is against GUID now. Which means that we don't need any of those implementations here. Or still, do I need any? Why? Because it has to be domain entity like this. So this now refers this, so it just copies everything over here and just replaces the TK with the GUID, so this will be GUID ID. You usually have to specify it still in several places. Wherever you need a actual final instance of the thing, then you need to specify what the key is there. That's why we have this domain entity, which is kind of like our default implementation. Kind of, if you really want to do things universally, you can totally remove this.
Yes.
And then let the user always specify the key. But this is just like inconvenient to write. So to make the code shorter, it's nicer to have some kind of one default implementation.
So to make it code shorter, you have to make it a bit longer.
Initially, you have to make it a little bit longer, yeah. So now I could theoretically write something like this. So what's the problem?
No, you don't need to write this.
Domain author doesn't have it. I have to do the author differently. So I can go to the here, and now I can say here that it should be an int, and everything went okay. And now I automatically have the primary key, the ID, as an integer, because it's coming from the domain entity, and domain entity is a generic, takes the TK, and the ID is defined via the TK. So the type of ID will be the integer. And everything will pick it up automatically, so Entity Framework will generate correct tables and correct SQL out of it, and all the types will change everywhere.
We show ID domain name.
And so this one now also needs int here. So base repository also needs the type now. But let's try to stick to those generics. So the universal ones. So I know that I want to base my real thing is out of this base class. So this is my common choice. So the weird implementation will specify some kind of different key. But normal ones will stick to the default key, so I can just write it like this. And then now everything is GUID. So now we have a bunch of our custom methods. So we don't have any cost. Yes?
So this is how we can easily, if you tell us what you use GUID ID, we can easily implement the different primary keys.
Yes. Yes. That exactly the same way as the identity user is done. So identity user out of the box, if you don't specify your own key, you will get a string as a primary key type, which is gets the value from the GUID, but it's actually a string, yeah? But then you can do your identity user and then point out with the generics that, hey, I want to get an integer. And then you get the primary key type as an integer. So this is how it's done. And now we have our repository. So we have the interface for it. We don't add any custom methods initially. And then we have the implementation for the author repository, which also doesn't have any custom methods. Because since the author repository is empty, it just derived from the base repository. So the base repository, ibase repository. And so the base repository already implements this ibase repository interface. So all the methods this interface needs are implemented here. So all those add and update and add whatever, update the sync and or get the sync or whatever we did there. Find the sync. So everything is there. And now we just need to use our repositories. So we are basically done with the stuff. So we can load back the web application and see what is going on. Reload the project. Controllers. Author, post. I don't even have author controller, I see. Yep, I don't have author controller. I've killed it somewhere. So let's add it back. Where's my readme? So I need this first line. And I most definitely have a bunch of problems with my database. I think my database is done differently. And we changed the meta fields around, we removed some stuff, and so my database definitely doesn't match. But let's do the controller. So let's go here. My Mac is fast as hell.
How long
Yep.
till the YouTube stream runs out?
Of what?
I don't know. When I think we should go to Echo because
Yeah, I think that it makes my life like really
because
bad
Echo
here.
works the same.
Echo works basically the same, so
Yeah.
so if you say that the delay is just 10 seconds, then it's totally like okay. So let's finish with this one and then we'll stop the YouTube stream. So let's just generate the authors controller again. Now I got the feeling how it's work with the like old laptop, where everything lags and doesn't open up immediately, and it's slow, and then it indexes, and then it doesn't show you the errors for like 10 seconds, and this is really annoying.
Should do it every day because then you will come back.
Through that, building project also takes like like a huge time, as I can see. So have you got some kind of grasp at least, I hope, what the hell are interfaces? So initially we don't use them yet a lot, like functionally. We write a lot of code via them, but pretty soon we're gonna use them. 5 errors. Semicolon, mis asja?
Semicolon is not good.
Build failed.
Yeah.
Categories controller. What do you speak about? Categories controller.
53.
Where?
53. Room number 53.
Yeah, but this is not moving normally.
But it was an issue. 53.
Really? Or slightly mad?
Sul ei mitte siin, vaata vist nii. Jaa, mis see oli?
Expected. Okay, this was we fixed a bunch of code here. Yeah, and we broke the code here a lot because now it also here string ID. This is not a string anymore. Bida
Ta on object string asjana.
category. I think what's wrong with the category? Okay, we have changed it everywhere. So okay, let's do this. Let's do the obvious choice.
Obvious.
Yeah.
To delete them.
Obvious choices. Let's kill everything.
Good choice. by the way.
Absolutely. And I can go and just kill the views also. So it's author, picture, categories, post categories, posts. Okay, now it should be better. So let's do it again. I think that since we have the JavaScript crowd now here also, so let's just fix quickly a few things and then we will continue in the ASP.NET with this thing. Since this is underneath, also you need to do the same thing in the ASP.NET project also, so let's grab some time from that lecture. So let's see how it goes now. Which was when maybe do 15. My computer is so slow, it's gonna kill me. If my computer would really work like this, I would like run like hell to the shop to buy the new one. What the hell? This is like unusable. Although
we should kill the unit stream.
yeah, I will get it now when I switch the lectures.
Yes, because
But
usually it takes like 10 seconds for something like that.
But
with a slow computer, like 20 seconds. This is super slow.
still, what the hell?
Super slow.
Maybe because of the complexity of the whole code.
Okay, I have ultra picture, there's a primary, Okay, let's stop with this one, and let's do the correct thingy from in the ASP.NET lecture. So let's switch over to JavaScript. So let's leave it just now as this. We have written our repository, now we just need to implement it and actually use it. So, and let's do it in the ASP.NET. So the distributed lecture will continue after the JavaScript lecture. So let's leave this one again alone, and now I will kill the YouTube stream, if I actually can.